Hi there. Welcome to another episode of The Alchemist Tells a Lie. Or two or three or four in this one. And actually, I want to remind everybody what that means. Just very briefly, is when I say that, it's basically meaning I can't tell you the whole truth. So in a binary situation, if I'm not telling you the whole truth, I'm telling you a lie. And we're going to talk about tempering today. And, you know, it's immensely complicated. To talk technical, which I don't expect you to understand, chocolate tempers or crystallizes in a polymorphic situation. And it's just immensely complex. And I don't know all of it. I've got a good grasp on it. And I've got 25 years as a chemist. And I've got a nice intuitive feel about it in sort of the artistic side, but also the science side. I get it, for lack of a better term. So when I say I'm going to lie to you, it's just that. I'm going to try to pass on that bit of comfortableness I have with how chocolate reacts and how it crystallizes. But some of it's going to be inaccurate, but hopefully it's going to get a point across to you, and that's really my intent. I want you to understand what's going on. Tempering gives everybody grief, or it seems to. And I think most of it is because people have a real difficulty understanding what's going on. It seems so magical. You hear all about, you need to have this part of it at one temperature, and you need to lower it to this other temperature, and something magical happens, and you raise it back up and, mold it up. And it's, classic. Well, why can't I just have it at the one of those two temperatures? What's with this up and down stuff? And people don't get it. I hope to help get you to get it. But I have to talk a little bit of jargon. The first part is chocolate. We're talking actual crystallization. And what I mean by that is, everybody knows salt, sodium chloride. You have a sodium atom, you have a chloride atom. Or ions, if you want to get even more technical. And they stack up in a nice, neat arrangement. And, that's a crystal. Many people have done rock candy. Those are sucrose crystals. And again, they form up in very nice situations or forms. Cocoa butter, the fat inside of chocolate, does the same thing. Unlike being little molecules, and wow, right here, it's a little bit more similar of this. You have, well, I'm actually going to pick this. You have an end, and you have this long tail in part of the cocoa butter. And actually you have three of these stacked together. 1, 2, 3. And it's called a triglyceride. Okay? And I'm going to just ramble here. Forgive me. Fast forward if you want. Hope you don't. And depending on how these three stack together, there are different ways they stack are called different types. And they're just names. So they talk about one stacking arrangement is type 1. Another stacking arrangement is called type 2. And it goes on up 3, 4, and 5, and 6 actually. The actual shapes, they don't matter. What you need to know is we want type 5. Type 5 is tempered chocolate. It's got that nice shine. It doesn't have a chalky feel, chalky mouth feel, in contrast to what we call bloomed chocolate. This is bloomed chocolate, and it's a whole bunch of different types of bloomed chocolate. You've got, and I have no idea which types these are. They're probably mixes of 1, 2, 3, 4. There's probably 5 in here. There's probably 6 in here. But what it is, it's not one crystal structure. It's a mess. It's bloomed chocolate. And we classify all of those. Anything that's not tempered, we tend to think about as bloomed. So anyway, our goal is type 5. All right. How do we get there? And there we go. That's back to those temperatures back and forwards. I guess what I need to explain to you is these are rough numbers. Here's part of the lies. Type 5 is stable at, roughly 88 to 90 degrees. We have to give that window, and here's the reason for that window. Those temperatures change depending on how much sugar you have in your chocolate, and what those glyceride chains, the acylglycerides, are made up of. So I'm showing this as we have a stack of 3 of these. The reality is some are slightly shorter, some are slightly longer, and that naturally occurs in cocoa butter, and you don't know what it is. You have no way of knowing, and they stack up differently. So what that comes to is, when you eventually factor it in, this forms at 88 to 90 degrees. These others fall apart at that hot temperature. They melt, for lack of a better term. And the common question is okay, and sitting right here is some chocolate. It's melted chocolate at about 100 degrees. So there are no crystals in this whatsoever. It's too warm. They're moving around. They can't do anything. If you cool this down to, we're going to split the difference and say 88 degrees. Logically, this should form. Makes perfect sense. Reality has a different idea about it. It doesn't form, or at least not in any reasonable time. It's just too energetic. For lack of a better term, this flops around too much. It's always moving. And it just can't come into a situation quickly. And so to sort of answer that, sitting at 89 degrees, it's going to keep flopping around. The crystals won't form. To get around that, what we do is we continue cooling it. And that's that first step that you've probably heard of, that you bring it down to, again, going to give you a range, 79 to 82 degrees. We don't really know what that range is, but what we do know is we can watch it. And we're going to do that in another video, or maybe later in this one. What you're watching for is the chocolate thickening up. That is your cue that lots of 5 is formed. Because you've cooled it and it can now start stacking together. Unfortunately, what happens is 4 and 3 also start forming. They start being able to form, and it disrupts the 5 forming. The result is bloom chocolate if you were to let it continue cooling all the way to solidity. So we don't let it go to this hard bit. We stop it at, again, just as it's thickening. And it's for a practical reason. Again, no magic. We let it stop, or we stop it just as it's thickening so that we can keep working with it. It's a pain to stir in thickened chocolate, or too thickened chocolate. So to give you an idea of, again, what's going on, we've had this hot chocolate, warm chocolate I should say, and we've cooled it all the way down to the point where it is solidifying. And we have, at that point, type 3, 4, and 5 in there. Mostly 5, but totally contaminated with 3 and 4. Okay? That was our trick to get 5 to form. We're now going to heat it back up, but just enough to make the 3 and the 4 start flying apart. The 5 won't fly apart. It needed the help to form, but now it's stable at 88, 89 degrees. So that's what we're going to warm it back up to. At that point, we've basically tricked it. We've got a bunch of 5 now. And at that point, if all of the chocolate is at 88 to 90, somewhere in that range again, we can now pour it up into molds. And with that large amount of what's called seed, type 5 seed, it's like a scaffolding now. It's all over the place, and the cocoa butter basically knows what to do. It will outcompete 4 and 3, and it'll propagate is what happens. And actually, in a way, if you can, we'll zoom in on this, and what you can see here is little circles, or they're not even circles, they're different shapes of polygons. But what you're seeing there is from in the very center there, just happened to be a little type 5 crystal. Just probably one. And it propagated out as this thing cooled. But there wasn't enough. And when they intersected, 4 got in the way, and you see a whole bunch of the bloom lines in it. And it was contaminated. So, you know, this wasn't a good one, and I just poured this up, and I got lucky. I'll just totally honestly. I got lucky to be able to show you this, how we had little dots of 5. So anyway, that's really what it amounts to, is that up and down stuff. It's tricking 5 to form. We then heat it back up to get rid of 3 and 4, and we let it set up. I want to talk about it, you know, and I hope that kind of makes sense now. I expect it won't. Watch it 4 or 5 times, listen to it again, ask me questions if it doesn't. The other part I want to make a point of is these are crystal structures. Again, I don't know if you ever made rock candy, but crystals, classic chemistry, crystals don't like to be disturbed. In that we stir chocolate is so atypical for crystallization. And as a chemist, I was wondering for years, why is this so different? Why does it work? And it's because it's a polymorph, as I mentioned, and polymorph means it has multiple forms. That's all that word means, by the way. It can crystallize in multiple ways. But what it does have in common with classic crystallization is it doesn't like to be disturbed after you finish stirring it and you've put it into a mold. So this one here, this I poured up, I wrapped it, I tapped it, but I didn't physically disturb it. I just left it as it was. And, you know, it's not blooming. It's really nice. This is the same exact chocolate. We went from this mold to this one. And I wrapped it, and I had too much. And what I did, and I did this on purpose so I could show this, is I came through and I swiped this. And then I came through and swiped it a couple more times. And what you can see here is those swipes disrupted those type 5 crystals. It broke them. And once you break the scaffolding, the chocolate, the cocoa butter doesn't know what to do. And so it's going to do just what it will naturally do. Without a pattern, it's going to form 3 and 4. And that's what it did. It formed 3 and 4 on the surface, exactly where I scraped it. And you can see right there, that, you know, totally follows. This really deep one, I just happen to remember, was a little piece of hard chocolate. And I sat there and I poked it in and covered it up with my finger. And you can see I totally disturbed it. And that's what's going on. Why did it happen? Well, I disturbed it. You can usually get away with a single swipe. It then covers and it's good. 2 or 3 doesn't work. So think about that with when you're pouring up. The less you can handle it, the better. You know, we're going to watch, I tend to pour right from the bowl. If you need to use a ladle, minimum ladling. Scoop, pour it in, scoop, pour it in. Under no circumstances sit here and try to flatten it out. You're going to have bloom all over the place. Because you're disrupting the crystals. You're breaking the scaffolding. It doesn't know what to do. It forms what's natural and easy. And that's all bloom is. It's natural and easy. So, all right. That's my rambling and set of lies and half-truths, but hopefully gives you a little bit of an understanding of at least how I think of tempering. The other 2 other points, actually, I do have it. if we, I think, I'm going to hope, if we flip this over and look, these are still setting up. We can see some concentric rings here as the mold flexes. And on this mold, we can see these concentric rings. I get a lot of calls, or no calls, I get a lot of emails from people wondering if that's bloom. And they just can't do bloom, or they can't work out how to temper because they get this. These are separation marks. They have nothing at all to do with bloom. They're a consequence of, and this is an extra light one, but well, molds flexing. That's what that's a consequence of. Really heavy-duty commercial grade molds basically make that go away. The mold can't flex, and it pops out all at once. These have enough flex, and so they sort of pry out, piece at a time. And what that does is usually you get these concentric circles as that's happening. Refrigerating sometimes helps. It makes it go faster. Doesn't always. And again, it's no defect. It's around all the time. So don't worry about that. Just enjoy the chocolate. You've tempered it really well. Last thing. Years ago, and I carry these still. So this is a chocolate tempering DVD. It is, what is it? It is the basics of successful tempering. It really has some nice techniques in it. I'm going to give you some basics and why we do what we do. And I learned a lot from this. And mostly what I learned was to relax. The person here tempers like it's nothing. She's very relaxed. And as soon as I relaxed, my tempering helped. I stopped swiping stuff and making bloom. I stopped overworking it. And it really worked very nicely. And hopefully I've given you some of the reasons why that works. So, this doesn't do it for you, look at picking this up. It's a nice one. All right. Thank you.